Hello, my name is Tree Hyun Yi. You can call me Tree, Christmas tree. I'm from Queens College, the city University of New York. This is a very popular concept. Yeah. How popular? If you Google resilience, you can get more than 5 million results with half second. What is resilience? Resilience refers to the capacity of a system to manage disturbance. Disturbance like a COVID-19, like a hurricane, like a snowstorm, flooding. This will cause a system, yeah, a body, a people, a person, a city, a country change. Like COVID-19 have to change with maskers. Restaurant have to be closed. Yeah, that's change. About this change with disturbance. You see here, we can see old people had low resilience to COVID-19. Young people had high resistance to COVID-19. Global warming can enhance jet stream, move the cold weather more suns to the Texas. The warm weather more to the high latitude. So Texas has a low resilience to snowstorm. Yeah, they have no good preparation, better preparation. No electricity blackout, a lot of car crash, no salt preparation. Yeah, New York City has strong resilience to snowstorm. You see this building near my home. What's that? No windows. That is for salt storage. There's many such. However, New York City has low resilience to the hurricane, right? Yeah. And this Ada, when it arrived to New York City, become tropical storm. However, caused a lot of problem. New York City has a low resilience to the hurricane. Yeah. Is warming, more water molecules condense into the liquid water. The rain is heavier. The water is so fast to fill in the basement, kill the people. Right? Yeah. And Texas has strong resilience to the hurricane. Even they have low resilience to the snowstorm because their houses in Texas have no basement. Yes, it's very popular because this paper and Dr. Holding and published in 1973. Yeah, and this paper is to convert its stability language in that only a few scientists can understand into resilience the most people can understand. Yeah. So this paper is about the link between resilience and stability. Yeah. I counted is a stability words like stability and appeared more than 6 times in this paper. Yeah, equilibrium, attraction, fluctuation, phase space. All these are the concepts from nonlinear dynamics. Only a few scientists can understand this concept. He converted this language into the resilience, resistance, recovery. Most people can understand. Yeah. These for the nonlinear dynamics system theory, the study a system. What describes this state of this system by state variables? State variable change with time is nonlinear function, and also function. And there is a environmental parameter or climate parameter. Yeah, and they want to study the equilibrium state, steady state stability. What is a steady state? What are the equilibrium? That means that the state variables do not change with time, determined by this steady state equation. Yeah. The goal is to determine this state equilibrium stability. The stability use this potential uh, chart to understand this equilibrium. So they give this terms. For example, I got a fever, so my body temperature going up. That's this terms. Yeah, my body temperature, fever temperature and the normal temperature. There's a difference. That is a perturbation. This perturbation, if it's stable, is decay, becomes smaller and smaller and smaller. Return back to the original body temperature. I'm stable. I'm health. Yeah. Not otherwise going up, going up. Yeah, that will go and will die. Yeah. So that's equilibrium. That's a steady state. Yeah. If it's stable, then the control parameter reach the threshold value. That's a stable, steady state become unstable. Yeah. So how do we know the stable? How do we know unstable? Let's study the difference. You give the perturbation, you give the disturbance. So this will be away from steady state. Like me, I got a fever. My body temperature going up. What's the difference between fever temperature and normal temperature? That is a fluctuation. So we can study the time behavior of this fluctuation. If alpha is negative, this fluctuation will become smaller and smaller and smaller. My fever is will be gone. My body temperature will return to my body normal temperature. That means I'm healthy. I'm stable. Yeah. So when threshold value, this stable state will become unstable. So there is this threshold value, this fluctuation is not decay, but become bigger and bigger. Then this system will tipping to another stable state, will be changed. Yeah. So they want to study this tipping point. Yeah. So global warming and half of land is drying, so that will kill the trees around the world. How? My question is, how dry is dry enough to kill the trees? That means what are the forest resilience? So we need the data. What are the data? Tree rain data. This is visiting PhD students from Beijing Normal University, Kaicheng Huang. He had done excellent job. You see in the vertical is the tree rain width. In the X, that is SPI is draft index. More negative, that means more drier. You see this robust relationship between, you see the tree ring become narrow and narrow as this weather become drier and drier. Yeah. Then at hydrate enough. At this point, no growth, no tree rain, no tree rain. Yeah, that's the tipping point. Just illustrates is how to calculate the term for resilience, resistance, recovery to the draft event. Yeah. So first things, what is a state variables? We described. We use the one variable, the y-index, to 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 represent the first growth. So this is called state variable selections. Yeah. Some use BAI, basal area increment. Some use children width index. Some use NDVI from remote sensing. Yeah. So next, we want to study steady state. Steady state is theoretical concept. That means this state does not change with time. How can we measure this steady state? Yeah, we use average, multi-year average of state variables to approximate steady state. Yeah. So and determines dry. This year, no precipitation, very dry. The tree growth is significant, reduced. So that's a fluctuation. That's between, uh, yeah. So how much reduction can be identified as event? Yeah. Sometimes use 25%, some scientists use 40% or 50%. It's up to research scientists. So there are a lot of formulation how to calculate resilience, recovery, and resistance. Yeah, by comparing this before this draft event and after draft event in the recovery process. So there is a many formulation. I cannot give you detail about this formulation, and however, you can find the details in my review paper. I have to point out the second author is Nathan Jackson, who was a high school student. He had done an excellent job to search these papers and create the tables of these indices. And these tables listed different resilience, recovery, resistance of the formulation, and also indicates what are the advantage, what are the disadvantage, and this is not only for the forest resilience, also for the soil carbon resilience, also for the hydrological resilience. Yeah, from this paper. Yeah. And this just 15 minutes limited. I cannot uh, give you details. Resilience is a very popular concept and for easy to follow up to understand, but difficult to quantify. There's an uncertainty in quantifying this resilience is rooted in the complexity of nonlinear system. Nonlinear system consists of many connection feedback. Yeah, and there's some feedback are positive that keep perturbation grows. Some feedback are negative to reduce this perturbation. Yeah, resistance, recovery, resilience are the results of this competition and collaboration between positive and negative feedback loops. Yeah, in the future, research topic should pay attention on the link practical resilience calculation to the feedback loops. Yeah, to identify the which feedback loops is other other control feedback loops that govern the others. Yeah, if policymakers, administrators, mayors, yeah, and the president, so they can find how to manage it. Governing feedback loop, then to avoid catastrophic disasters. That's all. Thank you.